In this video, we are going to discuss the following question. So given a number, find the first bit from right that is set in the binary representation of the number. So to take an example, let's say we are given input number n, which is equal to 4, which will have the binary representation as 0, 1, 0, 0. So we should give it output as number 3 because the third bit from the right side is a set bit. By set bit I mean the bit value is 1. So in order to solve this question, we will apply the following logic. We will check the rightmost bit, and if the rightmost bit would be a 0, then we will right shift the whole number by 1 bit. So we will obtain 0, 0, 1, 0 in the second iteration, and then again we will check the rightmost bit, and we will keep repeating this process until we will have a 1 at the rightmost position. As soon as we will have a 1 at the rightmost position, we will break out of the loop and return its position. So we will also declare a variable that will keep track of the position that we are checking. So its value would be 1 when we would be checking for the rightmost bit in the first iteration. We will update its value to 2 when we would have shifted the whole number by 1 bit to the right, and the position would be 3 when we would be checking the third bit by right shifting the number 2 times. So let's get to the code. We'll start by defining a method that will take the number as input. We'll check the edge case first. If the number is 0, then for sure it won't have any bit set in its binary representation, so we can just return -1 for this case. For all the other numbers, what we will do is we will run a loop, and at every iteration what we will do is we will find the value of the rightmost bit. So from our previous video, we know that this expression n bitwise and 1 will basically give us value of the rightmost bit. So if this expression is true, then we would have found a set bit at the rightmost position, and that is the time when we will break out of this loop. Otherwise, what we'll do is we will reinitialize the n by right shifting it by 1 bit, and we also need to declare a variable position that will keep track of the bit that we are checking. So initially we would be checking the first bit from the right, and at every iteration we will keep incrementing this position, and whenever we will break out of this loop, we will just return the value of the position. So this loop will actually keep on going until our number is greater than 0. So this condition will actually help our loop to end, because whenever we will right shift the number, we will be actually dividing it by 2, and it will keep becoming smaller and smaller, and at last it will become 0. So let's write our main function, main method, to check our implementation. We'll first check for the number 4. We know the answer is 3. For this, let's run it. And indeed it gives us 3 as the answer. Next, let's add some more cases. For 0, we are expecting the answer to be -1 because there will be no set bit in 0. For 2, we are expecting the answer to be 2 because the binary representation of 2 is 0, 0, 1, 0, so the second bit is set in this number. And let's add one more. Let's say for the number 3, we will be expecting the answer to be 1 because the binary representation of 3 is 0011, so the first bit itself is set. Let's run this one, and indeed we got what we expected as our output. I hope this logic was clear to you. If you have any doubts, then leave them in the comments below, or you can ping me on Instagram. Thank you. See you in the next video.